Our next lecture is Valentin Goranko. And viewpoints for logic, agency, and multi-agent systems.
Добре, кажи ми 6 минути преди края. Добре, спонсор поставя. Hello, Valentin, anyhow. It's a special pleasure to be here for the first time. Basically, this university is a beautiful place. I wish to thank Dimitar for the invitation and for the opportunity to come to see Bulgaria, which I used to remember from time to time. Yes. Okay. So, I will talk, well, my talk is announced as a keynote talk. And I must say that I don't give often, if at all, keynote talks. So I'm not sure exactly what you would expect, but I will keep it keynote in the sense that I will keep it broad and shallow. I'll not go into any technical details, but I'll make a number of points there that you may want to then ask me in the questions and answers session, and then I can expand more on that. One more thing to say is that I do not work specifically. Прикликнеш там горе на мор, може да махнеш този панел. I don't work specifically in AGI, but I work a lot in logics and multi-agent systems and logics for multi-agent systems. So what I'll talk today, I'll present you a kind of a perspective, my view point on AGI from the perspective of logic, agency, and multi-agent systems. So,
Кое да махнем след това?
Момент. Hide video panel.
Окей.
И това също.
И това?
Извинявай. Кликни отново тук.
Да.
Така, hide floating. Идеално. Сега. Ето. Sorry. On AI breaches. So this is more or less what I'm planning to talk about. First, I'll say some introductory words about agents, in particular intelligent multi-agent systems, and again, my perspective on AI. Then I'll say a bit more about how logic and AI interact, again, from my viewpoint, and from the multi-agent perspective. Then, time permitting, which probably will not happen, I can go in a little bit more details and tell you about, well, let's say, one universal way of modeling multi-agent systems that can be used as, well, building AI platform on top of it. And then at the end, I'll address the actual topic of this conference, namely, what's possible generation of AGI. Okay, so we'll see how it goes. But before I start, I want to start with a warm-up teaser, which actually I promised to pay back. Now, AI and AGI, this is about intelligent agents, but also about rational agents. So here's my question. Rationality versus intelligence. How are these two related, if at all? Now, this might sound like a trivial question, and not even very related to the topic, but in fact it is. And it's not trivial, at least because I've asked many people what they think. Some will say, well, this is about the same thing. Some others will say, no, they are not the same, but one implies the other, and then you get the implications both ways. And yet others would say, no, they have nothing to do with each other. And in fact, I'll tell you, I tend to side most with the last group. Not really nothing to do, but they are really independent from each other. If you want to hear my opinion on this, ask me at the end. But this is something for you to think tonight at the dinner while you're having your drinks. Good. Now, we move on. So, all right, first I'll say a few words about agents. And if you haven't seen agents, now here is some impression. Well, what I would say is actually some assumptions about what I mean about agents, particularly intelligent and possibly intelligent, but rational agents. And this is simply to make it a bit more clear, more precise, what I'm referring to when I talk about agents. So, first, agents are relatively autonomous. They can act on their own will, so to speak. They have knowledge or information. They have knowledge about the system, the world, so to speak, about the environment in particular, about themselves, about the other agents. That's important. And that also presumes that they have perception, that they can process signals, information processing, they have memory. So it's a lot. Agents also have ability to perform actions, or possibly using various tools. So, just a bit of an aside, in the old days, the beginning of AI, agents were purely mental sort of creatures. So they were not supposed to act. By the way, I teach philosophers. In philosophy, I tell them agents are not just philosophers, they actually act. They don't just sit and think. Agents have goals, that's important. They're goal-driven, or they can be, and they act in pursuit of their goals. They can plan their actions, and they can execute these plans, as we call them strategy, multi-agent environment. And last but not least, they can communicate, they can exchange information, they can cooperate and also compete and so on with other agents. And I'll turn shortly to the multi-agent perspective, but before that, say a few words about, again, my take or my view on what AGI is from my perspective. So, artificial general intelligence, well, it's kind of commonly defined or described as systems that are capable of human-level reasoning, but across various domains, and not reasoning, but also actions. So reasoning and actions across domains. And so this goes way beyond the narrow view on AI, which is past specific systems like playing chess and being able to sweep the floor and things like this. And so AGI involves, inter alia, a few important aspects. So first of all, an AGI agent, excuse me, you have the ability to model the real world, have an internal representation of the real world, and that includes being able to generalize to abstract features and so on. Then, of course, knowledge representation, very important, and this was one of the original applications of logic to AI, to provide a language and a platform for knowledge representation, and it is still the case. Agents do need internal and external knowledge representation to be able to communicate. Sure enough, we expect them to be able to reason, and AGI in particular should have a reasoning engine of abilities. And that also includes not just reasoning about what the world is, what the weather is, and so on, but also what I call strategic reasoning, that is reasoning about how to go about, how to come up with a strategy to achieve my goal, but also reasoning about the other agents and their goals. Then autonomous learning, which is something very important and specific for AGI, which is beyond, again, the traditional AI. This is the ability how to solve problems that the agent has not seen before, and without human interaction, that is autonomous. And then, this is a bit more vague, but it's still important. Common sense, adaptability, and much more. But let's say these are some features to this. Now, so there is an important kind of conceptual transition here for models to agents. And now I want to emphasize on the word agents here, because AI and AGI is or should be about agents and agency. It's not about some abstract creatures or entities out there. And in fact, actually, I think, and I'm not the only one to think, that an AGI, in fact, is an agent. And in fact, I would put it stronger. AGI is both a rational and an intelligent agent. And so, as I said, there is a conceptual shift here from thinking, that was the initial concept, an intelligent agent, the beginning of AI, from thinking to acting, to doing. And so, in particular, that implies that an AGI as an agent will involve, first of all, ability to autonomously set its goals. Immediate objectives, but also long-term goals. Ability to reason, against digit reasoning, I've already mentioned, and this is specific for agency. Planning and decision making, of course, very much related to the previous one. Then perception action loop, that is, well, the agent perceives, let's say, signals from the environment and process them somehow. And then based on this additional information, that is what the agent can observe and see and hear and so on, then it will take a decision or will ask its strategy, all right, what should I do now given this situation? And so that it comes up with a respective action, just an immediate action, but also a plan of action, course of action, and then acts, and then, well, the environment will changes, and then again, we're back to the loop. Right. So there is much more to say on this, but I'm just ballparking. Right. So all this is well good, but this only gives us a one-sided perspective from the whole story, that is a single agent perspective. And in reality, agents do not act in isolation. They act in an environment with other agents. And so that now I'm moving to my next point, which is the view on multi-agent systems. Some versions. So, what I mean by a multi-agent system, again, very briefly and schematically, well, this is a set of agents that act in a common environment, we can call it a system, playground, arena, and so on, in pursuit of their individual or collective goals. And so this is really a very broad concept, and it includes many and diverse examples. For instance, well, beginning with multiplayer games, soccer game, teams of robots, distributed systems, computer networks, but also social groups and networks. General institutions, business companies, markets, and so on. This university is a multi-agent system. So there was a play by Shakespeare called As You Like It. Was it Nabokowski? Kako is a person. As You Like It, and it it says, all the world's a stage, all the men and women merely players. What I think we have in mind, in fact, is that the world is a multi-agent system, and we are all merely agents in it. This is bizarre. All right, so multi-agent systems. Now, let us put together AGI and multi-agent systems. So, in my view, again, I'll say several times that I'm giving you my perspective and my view on this, and I do not claim that this is the one and only or the best, but I think I can justify and argue my perspective, my position. So, AGI relates to multi-agent systems in at least two different ways. First, that AGI is about agents acting in a multi-agent environment. So this is the kind of the external perspective, but also there is an internal perspective that a fully developed AGI is itself a multi-agent system. And I'll say a few more words for me. So this is the kind of internal perspective. And I'll start with the second perspective. And so this is again the conceptual shift from a single agent AGI to a multi-agent AGI, which I think is still very much in the making, even conceptually. I'm not even talking about practically. And well, maybe one of the most kind of popular theories that lie behind this conceptual shift is the so-called swarm intelligence theory. And we talked earlier about this, we can talk much more about. But that gives you an idea. And also Marvin Minsky was mentioned earlier. And so this idea actually goes back to him because he would inter alia say that intelligence is actually a large collection of small non-intelligent components, which I would call agents. I'm not sure whether he did, but I would call them agents working together. I think this is really a very insightful view on what intelligence is or should be, in particular, AGI. So then multi-agent AGI as a team or a complex of component agents should inter alia involve first common goals, key. And well, designing joint strategies for the components or the agents in the team for achieving this goal. Then, well, component agents, I call them component agents for lack of better word. Maybe I should use these or ants. Yes, component agent specialization. So that includes, different agents will have different specific functions and more abstract level. For instance, we can talk about controllers or orchestrators or many others, directors and workers, you name it. Right, interaction and coordination. This is very important. This is crucial for any multi-agent system to function the way it should be. That there should be a good way of interacting and coordinating amongst the components, and modularity and scalability. And these are specific but very important aspects that are not in general assumed and required for multi-agent systems. Multi-agent systems can be very rigid formations, but if you really want to model or represent an AGI as a multi-agent system, then these are crucial features in my view. Also crucial features, robustness, self-organization, and there is much more to this here, but I will mention just one more, which links to multi-agent reinforcement learning. If you have heard of this, and if not, then just pass further. But there is much more to say. Again, I'm saying I'm only bookmarking important points here. Okay, and by the way, there are some I would say prototypes of our implementations, but Microsoft's AutoG or OpenAI Swarm are some such implementations of at least partly this idea of AI or AGI as a multi-agent system. Okay, so now the other perspective, the first one that I listed, which is closer to my own research and interest. This is multi-agent systems looked at as AGI systems, so that I just came up with this term multi-agent AGI systems. I'm not sure if it exists or not, but now it already exists. So a multi-agent AGI system models the interaction of AGI agents, so that now the idea is that each of the agents is by itself an implementation of an AGI, but they act and interact in a common environment, and so that now we talk about multi-agent AI system. And so it should involve, again, looking at the bookmarks here, it should involve now not only collective or team goals, but also individual goals. Okay, take a society of agents, so each agent may have their own goal, but there are also groups of agents, they may have group goals or collective goals, and then we can talk about societal goals of all agents, right? So there are different levels of goals, and again, designing strategies for their achievement, reasoning about this, and so on. Then agents communication within and between the groups. These are two different types of communication with different purposes, but they are both very important. Well, again, typically in a multi-agent system, there will be some hierarchy. For instance, take a university or any institutions. This hierarchy from top to bottom. There are various dependencies, hierarchical and other dependencies between them. So there is a structure on the set of agents. It's not just a set. Agents interaction, again, that's very important. Well, it partly actually overlaps with this, but I'm talking now specifically about interaction that ranges over different patterns. There are different patterns of interaction. We can talk about collaboration. We can talk about competition, and anything in between. And in real life, the interaction is really some complex mix of competition and cooperation. That by itself is a deep and important topic. Okay, so I'll make one important point, which is further in the slides, but probably I'll not have time for it, is that agents in a multi-agent AGI system, they act in their what I call social context. And I'll say again a bit more at the end if I have the time, what that means. And they also act under various normative constraints, which is very important, which links to the general topic of the conference. Again, that would come at the end if I get it. So, all right. Just a few words about logic and AGI. And after all, I'm first of all a logician, trained. By the way, one of my teachers from the university sitting here. So I'm really amazed that 4 years before my retirement, I get to lecture to one of my teachers. Well, it could be repeated clearly. But anyway, so logic. Well, as you all know, probably there are two main schools in AI. Historically, well, the first school, the beginning, that is more or less when I was born, late 1950s, logic was really pivotal, I would say, fundamental for the early AI development. But lately, and especially nowadays, it all changed radically, and some people would say logic is already irrelevant. So, of course, I totally disagree with this, but yeah, most people don't even see the role of logic in. Okay. So the old school is the so-called symbolic AI, which was mostly about logic-based knowledge representation and logic-based reasoning, deductive reasoning, and expert systems, and automated reasoning, and so on. Right. And so it had his degree of success, and even there was big hopes for it. In particular, I had this Japan's fifth generation AI that kind of failed, but not completely. So anyway, the new school came, especially over the past 5-10 years, which is, I would say, the neural networks-based AI, which is actually what the LLMs use. And so it is essentially based on statistical reasoning. And even though we use the word reasoning, but it's very different from the kind of formal logical deductive reasoning in the way that probably most of you at least intuitively know. Right. So what is the next step? These two are clearly different, and in fact, they are kind of in a conflict. They are very conflicting concepts, ideas about how AI should be. So, of course, what is the next step? Well, if you studied ideal like this in your preschool, you will know. And so the next step would be to combine the two into neural symbolic AI. I've not come up with this concept. Well, this is already there, but it is yet to be actually implemented. So that the idea is that it combines neural networks and logic in a meaningful way, not just mechanically. That is integration of statistical reasoning and learning with deductive statistical reasoning. And learning will come from the new school and deductive will come from the old school. Because every one of you who has had some experience with AI tools, you know that, well, they can look very smart. You ask them a question, they give you a very confident answer, and it can be utter rubbish simply because they don't have the judgment they don't have a mechanism to judge the logical correctness of what they are saying. And you cannot blame, of course, the tool itself. That's part of the whole design. So anyway, that's a bit of an aside to move on. So again, what is the benefit of this interaction? So the idea is to take the advantages of the two approaches, namely from logic, take the advantage of providing a framework for correct and reliable reasoning. Well, this is the slow thinking, if you read Persian Kahneman's book, and the LLMs that give you the flexibility, efficiency, and a lot more. And this would be the fast thinking. So combining the slow and fast thinking is the key for the future development. Now, so there are, of course, various limitations. I'm still waiting for the 10 minutes warning, which means that. All right, so I can talk for another 5 minutes and then we have 10 minutes. Yeah. Okay, good, fine. All right, so I know. So I feel that I'm starting to rush, and so good. 5 minutes, good. So there are, of course, obvious limitations of logic, and there are various technical challenges for its integration. And so this is not a simple task. This is really a huge challenge now, how to do this integration. Well, to begin with, slow thinking is computationally expensive. It takes a lot of time, space, resources. It's really, even though now the hardware the computers are much more powerful, but still you hit the boundaries. Then, of course, traditional logic also has no intrinsic learning mechanisms. In a sense, the logic-based systems are static in the sense of what they know and what they can do. And it is also, for instance, it It has a relatively poor handling of uncertainty, which is ubiquitous. We have to reason within uncertainty, cannot be otherwise. There have been various approaches indeed, some more successful than others of developing logics for probabilistic reasoning or fuzzy logics and others, but it's not fully there. So, all right. Well, maybe I should, after all, use one slide as kind of advertising slide. So this is, as you see in the clips on YouTube, in the middle, in the most interesting part, there is a post and an advertisement. So my advertisement is why logic? Why logic for multi-agent systems? Well, there are many good reasons, and I'll list some of them. So formal logic gives a uniform, expressive, and technically powerful framework for many things, including, begin with, formal representation and modeling multi-agent systems. Not only, of course, but now in this context. Knowledge representation in formal logical languages that are equipped with precise syntax and with an unambiguous formal semantics. And this is of crucial importance to be sure that whatever and whichever we communicate with each other or artificial agents communicate with each other, they understand each other correctly, they do not mislead each other intentionally or not. This is very important. Well, everyone who uses natural language, like is everyone here, we know that natural languages are ambiguous and so therefore they are not reliable for crucial tasks. And this is one of the major kind of conceptual advantages of logical formal logical languages. So again, this is stated as an advertisement. I'm sure that most of you know this, but when you're listening to an advertisement, even you have heard it 50 times, you still listen to it. So, okay, then formal specification of properties of multi-agent systems using these languages. That is, for instance, if you want to design a multi-agent system or you want to verify, you want to check, I'll come to this shortly. Well, first step would be to actually say exactly and unambiguously, precisely what you want this system to be doing. Well, then it's also important that logic helps for kind of a conceptual analysis of a particular multi-agent system, what it does, how it does it, and so on. And especially in the context of AGI, I think this is very important. And of course, well, the kind of historically first reason for which logic was designed, this is formal logical reasoning, both within and about multi-agent systems, using various systems of detection that have been developed, and there are new logics come up virtually every day by the dozen for specific purposes. But in particular, it's very important, or that is, one important application of logic is for in particular for the deductive reasoning, is for ongoing sort of real-time consistency checking and consistency maintenance of the agent's both factual and higher-order beliefs and reasoning. That is, well, in the real world, agents have some beliefs, things happen, agents get to observe or learn things, communicate, so that they change their beliefs and they get to, for instance, well, they receive contradictory information, and so they have to deal with this. Formal logic will tell you if you have a contradiction, then everything falls apart, it becomes useless, so that you need some mechanism for kind of belief revision and maintaining consistency of your beliefs. It's very important, in particular for AGI. Again, then formal verification of properties. So it's not only sufficient to specify what you want the system to do, but to be able to formally, that is algorithmically, thank you, verify it. This is one of the major and huge applications of logic in computer science so far, and it will be no less application in AGI. And in particular, there are new aspects of this applications, for instance, for how to make the design of agent strategies or entire, agents or communication protocols, controllers, and you name it. So there is a lot more to say here. I'll not say it, but I will come. Okay, I skip this completely now. And then I will jump to, yes, some examples. And then I will jump to, and yes, I also have to skip this because I promised 10 minutes for discussion. But there is a kind of one relatively recent overview of some formal logical systems that have been developed by myself and collaborators and others for reasoning of different aspects about different aspects of multi-agent systems. So, right now, last a couple of minutes just to wrap up and to address, after all, the main topic, right? Otherwise, you'll tell me, all right, now you're talking something different than what we invited you for. So, logic, multi-agent systems and responsible AGI, to put them in one story. Well, there are really many and various aspects of this, and I'll mention just two of them. First is strategic reasoning of and about rational AGI agents in what I call social context. And it's on the slides, but I'll skip it. And the second is strategic reasoning in multi-agent AGI systems with normative constraints. I have a couple of slides on each, but I'll skip them. If you're interested, ask me or talk to me. So let's see now. What is my last slide? Yes, closure. So, well, again, one of my main points is that intelligent agents and multi-agent systems are crucially important components or aspects of artificial general intelligence. It is about agents and their interaction. That is my take, my viewpoint. Next is that formal logic provides a reliable and efficient methodology for reasoning about intelligent agents and multi-agent systems, and consequently about AGI. And this is really where logic can find not just a kind of formal nominal application, but a real true and important application there. So I'll end up with a kind of a slogan. If I am to define an AGI, or specifically multi-agent AGI, on one line, so this is what it would be: reasoning plus learning plus autonomous agency plus multi-agent interaction. And I'll end on this one. Do I have questions? Then I will finish my lessons. You better have some.
I want to ask a question. Multi-agent AGI. This is AGI which understand that he's not alone and there's in the world there's other agents, or it is compound of many parts. This is like society. It's like many individuals.
Well, it's both. I mean, as I presented, I see two different views on what one can call multi-agent, or how AGI and multi-agent systems come together. One is the internal view, where you look at AGI as a kind of a complex of component object. That is, the AGI itself is a multi-agent system.
Mm-hmm.
But the other one is when you look at a multi-agent system consisting of AGI agents, that is, agents, each one of them bearing or implementing an AGI engine, so to speak. And so these are two different but kind of complementary components. And of course, you can have both. I mean, generally, you have both. And in fact, you have a hierarchy. It's like, matryoshki, if you know what this is. So it's really small complex, but this is, let's say, one level. Yeah.
More like a comment, if I may. Before your lecture, I struggled like with what might be the future, but agentic approach totally corresponds, and the swarm intelligence that you already mentioned. Now I see, and there is already market indications of orchestrating agents in a way like this multi-agent approach already being in place for certain practical aspects. So definitely, that's
So indeed, you're right. There are many kind of concrete, specific stories or implementations of much of what I say here, but still the general framework, the whole story is yet to be written.
Nevertheless, I appreciate your vision for the future present. Thank you.
I think it is.
Okay. Great. Okay, let's say it.
Well, I think I managed to change away like 10 of your
No, there was
I hope it was
because of the rector.
Yeah, I hope it's not just because of me, but it's also because they want to.
So many tasks.
Oh, okay. So, good.